Hey, today we're going to talk about what a mathematical function is. First, a definition. A function is any math relation that meets the following three criteria. It must have an x value. We call that the input or the independent value. It must have a y value. We call that the output or outcome, and it's the dependent value. And each x must yield one and only one y value. So there is a very special one-to-one correspondence there. Now the x value we call the domain. So anytime you see the x value, I can simply call that the domain value. The range would be the set of all of the y values. Now, there are three different ways that functions can occur. They can occur as ordered pairs. They can occur as equations, and they can occur as graphs in the algebra classroom. So those are the three types of functions you'll be seeing. Now, for ordered pairs, notice the ordered pairs in my first example under Objective 1. It asks us to find the domain and range. Now remember, the domain would be all of the x values. So I would simply pick those out. The x values would be 0, 10, 20, 30, and 36. 0, 10, 20, 30, and 36. The range would be the y values. The range is 9.1, 6.7, 10.7, 13.2, and 17.4. That's it. Now, how do we know if an ordered pair set is really a function or not? All of the x values must be different. Notice in my first example A under Objective 2. Remember that criteria that's the one-to-one relationship? In this first ordered pair it says 1 goes with 2, 3 goes with 4, 5 goes with 6. However, in the last ordered pair, it says 5 goes with 8. That's like being married to two people at the same time. Legally, that's not supposed to happen. So the x should not be duplicated there with two different y's. If you see that, then that is an example of ordered pairs which are not functions. Now, in example B, under Objective 2, I notice I have a 1 with a 2, a 3 with a 4, a 6 with a 5, and an 8 with a 5. Notice that all of the x values are different. It doesn't matter if the y values are the same. As long as the x values are different, we can say that this is a function. When a function is an equation, you will look at the x and y values again. In particular, the y variable should never have an even exponent. Functions never have an even exponent for the y value. So in my first example, I look at my exponent on the y and there is none. So that's an understood 1, which is an odd number. Odd exponents for y values would be correct. So this is a function. However, on my second value here, you may recognize that as a circle equation because both y squared and x squared are present. Since this y has an even exponent though, it would actually fail the test to be a function. So this second example is not a function. When you can determine if graphs are functions or not, we will use something called the vertical line test. The vertical line test says that if any straight up and down vertical line crosses a graph at only one point, then it is a function. However, if you have a graph that you can draw a straight up and down vertical line through and it crosses at more than one point, then this is not a function. That's how the vertical line test works. Now let's look at function notation. Function notation looks like this, an F with a parenthesis and an X. We would read that as F of X. And the Fx notation actually replaces the Y in the equation. So notice in my example here in Objective 4, instead of Y equals that equation, I have the F of X, but the Y and the F of X are interchangeable. Now we use function notation to help us know what the input or the X value is. In this first example A, it has F of -5. That means to replace the X with a -5. So in the original problem there, I'm going to replace that X with the value of -5. Now I use parentheses because it will help me keep my signs correct. -5 times -5 is 25. -2 times -5 is +10. And then of course when I add this together I end up with 42. So my answer for F of -5 is 42. And that's how you use the function notation. Now in this second example B, I am going to replace the X with X plus 4. So I will take the original problem and everywhere there's an X, I replace it with X plus 4. Again, you'll notice I use the parentheses just to keep things in the proper order. Now, X plus 4 squared means I have 2 of those, and you will recall we had used the FOIL method, first, outer, inner, last, to multiply that. So I do need to simplify. X times X is X squared, and then I have a 4X and a 4X. You write that down. And then 4 times 4 would be 16. In the middle here, I notice that I have to use the distributive property. So I'm going to have to multiply that -2 in front. So that's going to give me a -2x and a -8 and a +7. From here, I simply need to combine like terms. So I have my X squared, let's see, 4X, 4X, and -2X. That's 8 minus 2, that's going to be 6X. Then I have the 16, -8, and +7. Let's see, 16 minus 8 is 8, and 8 plus 7 is going to be 15. This then is my final answer for F of X plus 4. Now for my last example, I have to replace the X with a -X. So I'm going to have -X squared minus 2 times -X, still using the original problem I'd started with, and then plus 7. Now negative times negative makes that become +X squared. Negative times negative in the middle becomes +2X, and then I have plus 7. And that would be my last answer for using the function notation.